All right, we're going to look at this example. It's another separable ODE. So that's obviously a function of x alone, and that's obviously a function of y alone. We're also given an initial condition, so we should be able to find a particular solution without any arbitrary constants. Again, we separate by doing this, or pretending this is a fraction, and cross multiplying, dividing, and then we integrate. So okay, so that's our separated integral, and these integrals are trivial. This is a log, and that's a polynomial. Now, we should actually be careful. I forgot to mention that this step here has a caveat on it. Y cannot be equal to 0 because we can't divide by 0 on the left-hand side. Note that if y is indeed 0, we've got a stationary point. dy dx is 0. So you can kind of fill in that hole later. So we've done our integral. We've gotten log absolute value of y, and note that I'm taking care to include the absolute values. All right, and we'll see what happens to them shortly. This is invertible. We know the inverse function of logarithm. It's exponential. So we've got e this is what we've got. Now we've got to try and deal with this absolute value. And our first step to dealing with this absolute value is to recognize that e to the power of c is another constant. So recalling our exponential laws, we can write this. So it's still absolute value of y equals e to the power of c, e to the power of x cubed on 3. Absolute values are either positive, right? It returns a positive number if the value is positive, or it returns a positive value if the argument of the absolute value is negative. So one way we can actually do that is we can use the plus or minus symbol in place of the absolute value. So it's either plus if y is positive, or it's minus if y is negative. All right, so it's not, plus and minus doesn't necessarily invert the absolute values, but this is just the outcome of taking the absolute values away. But what we realize is we can actually hide the plus and minus. Plus or minus e to the c, it doesn't matter whether it's plus or if it's minus, that's still going to be a constant. So that's just another constant. We can relabel it, and we arrive at a e to the x cubed on 3. Now, we have an initial condition. Our initial condition was y of 0 equals 1. And we proceed by substitution. We say we apply the initial condition, y at 0 equals 1. So that's 1 equals a e to the 0 cubed on 3. So that's 1 equals a when we simplify it out. Okay, just the naughty case. If y equals 0, that's directly integrable. So y is a constant, y is equal to 0. And that's what we call the trivial solution. So if you do end up with dealing with that, that's also a solution of the ODE. So where we excluded it in our separable case, we can actually just check that y equals 0 does still work as a solution to this problem.